So the first video from chapter 9 is on work from constant forces and the work kinetic energy theorem, and this is covered in chapter 9-2 of the textbook. Okay, so first off, what do we mean by work? So in physics, work has a very specific definition. In particular, it's there's different ways to define it, but the way it's done in your textbook is that it's the amount of energy transferred to or from a system by an external force. So, and for a constant force, so you can calculate the work as the product of the magnitude of the displacement times the component of the force parallel to the displacement. So it's a force times a displacement, but the key thing to remember is that it's the component of the force parallel to the displacement. Or alternatively, you can think about it as the component of the displacement parallel to the force. They're equivalent. Now, just like we had with energy, work is going to have SI units of newtons times meters, which is kilogram meter squared per second squared, as we saw last chapter, is also known as a joule. So, and again, just like we had with energy, so work is a scalar quantity. All right, so this brings us to the work kinetic energy theorem. So if you apply some net external force, it's going to change the motion of a system, and hence it'll change its kinetic energy. And in fact, the total work done on the system, or the net work done, must equal the total change in the kinetic energy. So the net work done on the system has to be the net force times the displacement. And if, again, we're assuming that the force is constant, force is mass times acceleration, we do a little bit of kinematics, and you can get that the net work done is equal to the change in the system's kinetic energy. So this is the work kinetic energy theorem, which says that the net work done on a system is equal to the change in the system's kinetic energy. So just note here that this is the total work done on the system. So you have to include all the external forces that are doing work.